Okay, hello guys, hello. Those who are joining in, this is a maths channel, maths game. Maths is a game. Um, anyone here right now who'd like to get specific help on anything that is maths related, grade 8, 9, 10, 11, 12, you're more than welcome to actually drop your situation in the comment section. Okay. Okay, so we are going to be looking at some grade 12 trigonometry. Okay, and we'll kind of like be taking a brief look overview over the grade 12 syllabus where the grade 12 trigonometry is concerned. Okay, but to first get us off the blocks, okay, first and foremost, we need to know the identities from grade 11. All right, there are two identities. The first one being this one: tan of theta is equal to sine theta over cos theta. Very important identity, this one that needs to be known by every learner in grade 11. Then the second one is what we refer to as the square identity. Sine squared theta plus cos squared theta is equal to 1. Very important identity as well that we need to know. And in conjunction with that, you need to know how to write the same identity, making sine squared theta the subject. So if you have sine squared theta, okay, if you make sine squared theta the subject, you go transpose the cos squared theta, it becomes negative cos squared theta on the other side, right? That's another way of expressing. Also, if you make cos squared theta the subject, then basically also you need to note that it becomes 1 minus sine squared theta. This also coming from the same identity. Very, very important to know these identities. Then, in grade 12, we have what we know as the compound angles. So the compound angles for grade 12 learners are: 1, you have this compound angle that we refer to as the sine of, let's say, a plus b. Okay, you could put any other variables here, okay, but it's the addition of two angles, the sine of it. The way that we basically express it is we say sine a cos b, right, plus, since there's a plus there, we put a plus there as well, but it's sine a cos b followed by cos A sine B, in that order. Okay, that's the addition of the compound angle for sine. In the same vein, the subtraction of the angle as well will basically be of the same substance, sine A cos B minus, since there was a minus sign, we write minus cos A sine B. So this is for grade 12 learners, the compound angles. We expand the compound angle sine A minus B by writing sine A cos B minus cos A sine B. So that's one. Then two, something to note. All right, this here will always be available in your formula sheet. So it's not like you need to know it off by heart, but it's helpful when you know it off by heart. Yeah, you can do so. You can definitely screenshot. Okay, I'll definitely show you, all of them. Okay, sort of like what I've written down. So there's another compound angle for cos. So cos A plus B, slightly different from this. Okay, so here's the thing. The way I tend to want to remember is sine means same. So the S for sine means same, meaning same sign. If it was positive, then you have positive there. If it was negative, you have negative in between. Then it's a matter of remembering that the A and the B follow each other, but then it's sine, cos, sine, sine, cos, sine. So basically same sign, okay, plus it was positive, it's positive still, it was negative, it's negative still. And it's just a matter of saying sine A cos B, cos A sine B, sine A cos B, cos A sine B for same signs. C cos on the other hand means change of what? Change of sign. So basically what we do is we say cos A minus B is basically cos of A cos B. So slightly different from this, okay, is that we say cos, and then the sign changes. If it was positive, it becomes negative, and then it's sine A sine B. Okay, then if we have cos of A minus B, in the same vein, you'll have cos A cos B. Since it is negative, then you say plus sine A sine B. So, like I said, grade 12s, okay, you need to first know the identities that you learned in grade 11, which was tan theta is equal to sine theta over cos theta. Then you need to know the square identities. Sine squared theta plus cos squared theta is equal to 1. Then you need to know how to express this same identity, making sine squared theta the subject. You basically know that you transpose the cos squared theta, it becomes 1 minus cos squared theta on the other side. Same thing with cos squared theta. If you make it the subject, you're basically just taking sine squared theta over to the other side, and you write it as 1 minus sine squared theta. Then this is the grade 12 compound angles. This is how we expand sine A plus B. Alright, please people, the way we expand it is we just say sine A cos B, and then the plus sign is still the plus sign. You have cos A sine B. This is in your formula sheet, so this is really, like, if you know it off by heart, it really helps, but it's in the formula sheet, so you can always refer to the formula sheet and use it whenever you feel that you need to expand a particular compound angle of sine. Same thing with, so that's the addition. The subtraction, in the same vein, just have the same sign as the minus. Okay, so same sign, but then with cos, the addition of the compound angle for cos is basically you have cos A cos B minus sine A sine B. So here there's a change. C stands for change. There's a change in sign. Plus also you can see this is cos sine sine. Cos sine sine for cos. Then we move on to something called the double angle. So for the double angle, we have sine of 2a. And the sine of 2a is simply 2 sine a cos of A. Very important, guys. That the sine of 2A, this is not sine squared, it's sine the double angle. Double is equal to 2 sine A cos A. Okay. So the double angle for sine only has this expansion, 2 sine A cos A. Then we have the double angle of cos. Okay. The double angle of cos has basically 3 ways that we can express the double angle of cos, and we need to be familiar with all 3 ways. The first way is cos squared A minus sine squared A. This double angle of cos can be expressed as cos squared A minus sine squared A. Do not confuse this with that. Okay, this is the addition of the square, sine squared theta plus cos squared theta. It gives you 1. Whereas this here, you can see this is cos squared A minus sine squared A. It is equal to cos 2A, the double angle of cos. That's one way of expressing it. The other way is saying 2 cos squared A minus 1. That's another way of expressing the same double angle, but where there's just cos in the mix. Then the other way is 1 minus 2 sine squared A. This is another way of expressing the double angle of cos. So these are 3 different expressions and expansions of cos 2A. Cos squared A minus sine squared A, 2 cos squared A minus 1, and 1 minus 2 sine squared A. Okay. Now, in the mix of that, we should not forget our grade 11 work that we did, where firstly, we learned about what I refer to as the function values. There was 180 minus, 180 plus, and 360 minus. All right, and there was always an acute angle. Acute, and acute angle is an angle between 0 and 90. So remember, guys, that we know that when we have to reduce something from an angle that is greater than or maybe less than 0, and basically want to reduce it to an acute angle, we use these function values. Okay, and we learned this in grade 11, 180 minus theta. All right, and obviously now in this grade that we are in, grade 12, okay, if using this ASTC seems to be a pain, and you cannot basically write down the reduction of 180 minus theta by basically saying 180 minus theta is in which quadrant. We know that 180 minus is in this second quadrant. How is sine in that quadrant? It is positive, so then we write sine, and then 180 minus falls away, we write sine of angle theta, which is positive. The way that now, if you are really confused, you cannot really do it. The way that it's easy to do now, guys, is you simply just write in the sine, and then you read the brackets there, okay? So you just say 180 minus, and what you do in this place, you substitute just any random acute angle. So usually people like substituting 1, because remember 1 degree is something that's between 0 and 90 degrees. You close the bracket and you just say equal. What you get is a positive answer. That would suggest that the sine of 180 minus theta will give you something that is positive. And then all you do is you simply say sine of the 180 minus falls away, you write sine of theta. Let me just show you again with some other examples. So you say 180 plus theta. Let's say you tend to forget, or you tend to mess up the sign of sine 180 plus theta. You don't write the correct sign, positive or negative. So like I said, 180 plus theta, you can go to your calculator and just go and substitute in the place of the theta, you substitute 1. Now you see this is 180 plus 1. So you have sine 180 plus 1, and all you want to do is just check the sign that you will get. Guys, do you see the sign that you get is negative? Do you see that? So therefore, that just means all you're going to do without really thinking, since it's a function value, this one you just say minus sine of theta, and the sign is already catered for. How you would do it using the Cartesian plane, you would say 180 plus theta is in which quadrant? Then you would say it's in the third quadrant. How is sine in the third quadrant? We know that in the third quadrant only tan is positive, so sine in the third quadrant is negative. Then you would write negative sine of the acute angle, which is negative sine theta. So if you want to avoid thinking about the Cartesian plane, because sometimes you mess up the sign, all you need to, in the place of theta, substitute a random angle like 1, and then you just say equal and check the sign of that particular value. So it gives you something that is negative, and all you do then is you write negative sine of theta. Okay, check this out. 360 minus theta, you do the same thing. Sine 360 minus theta, all you do to simplify this, you just go to your calculator, you go and type in 360 minus, and then you just say minus 1. You say equal. What is the sign? It's negative again. So basically that means your answer will be negative sine of theta. Okay, so this is a shortcut to try and avoid this, the thinking, because sometimes people, they mess up writing the correct sign. So this is a shortcut method to try and help you to avoid that. So those are your function values. Okay, and your function values, like I said, are simply, your function values are 180 minus, 180 plus, and 360 minus. All you can now just do is just substitute 1 in the place of theta so that you can be able to know what the sign of that particular trig ratio is. So it's positive sine theta for 180 minus theta. It's a negative sine theta for 180 plus theta. It's negative sine theta for 360 minus theta. And you can just evaluate that using your calculator without having to think much. Then remember, there's something that we refer to as our co-ratios, or our co-function values, if you want to call them that way. Function values, the co-function values, they basically include your 90 minus, 90 plus, and I want to stretch and say 270 minus and 270 plus. Okay, this is where if you have sine theta, the sine theta will change to cos theta. And if you have cos theta, the cos theta will change to sine theta. So just a quick example for that. If you have sine 90 minus theta, for instance, you do the same thing. 90 minus theta is in which quadrant? It is in the first quadrant. How is sine in the first quadrant? It is positive. So then you write your answer as positive cos of theta. Why? Because since you have 90 minus, which is a co-ratio, that the trig ratio sign will change to cos, because that's what happens with our co-function values, or in other words, our co-ratios. You express your answer, with, if sine was basically the trig ratio being used, then sine changes to cos. But that only happens with 90 minus, 90 plus, 270 minus, and 270 plus. And the way I like to think of it is that the change only happens, because if you have a Cartesian plane, this is 90 degrees, this is 270 degrees. So for the verticals, change happens. But for 0, this is 180 degrees, back here it's 360. So if you are doing 180 minus, 180 plus, 360 minus, or 360 plus, then there's no change in trig ratio, just the sign. But for 90 plus, 90 minus, 270 minus, and 270 plus, there's a change in the trigonometric ratio from sine to cos, or from cos to sine. So let me just do another one. Cos 90, for instance, plus theta. So in the same vein, this is a co-ratio. So there's going to be a change in the trig ratio, of course. 90 plus theta is in which quadrant? It is in the second quadrant. How is cos? Cos is negative. But then we express the answer as the changed trig ratio, which is sine. Because cos changes to sine and sine changes to cos for your co-function values. And please, guys, maybe you want to do the shortcut for the getting the sign correct. Please do that. You can do that here. Just that you need to remember again. So you have 90 plus there. Say 90 plus. We just put in the 1 there. Because what do you want to do? You just want to check what the situation for the sine is. Okay, sorry, the trig ratio was not sine, it was cos. So let's just quickly change the trig ratio to cos. Okay, so it was cos 90 plus theta. We got negative sine theta, but I just want to check if the sine really is like that. Look at that, cos 90 plus 1, you get a negative sine. Do you see that? So therefore, cos 90 plus theta is equal to negative sine theta. So it's only just a matter of remembering that if we have 90 plus, 90 minus, 270 plus or 270 minus, the trig ratio will change from cos to sine and sine to cos. The sine, your calculator can just help you. You just substitute 1 in the place of theta. You will always get what the sine of the expression should be. Okay, so that is just a quick summary, guys. A quick summary or overview of what you should know as you go into trig in grade 12. You can't go into trig for grade 12 not knowing all of these things that I have written down here. From identities, these two identities, all right, how to express them using sine squared theta as the subject or cos squared theta as the subject. You need to know the identities very well. You need to know the expansion of your compound angles for sine and for cos. Okay, you need to know the expansion of your double angles for the double angle of sine and for the double angle of cos. You need to know them very well. You need to know your function values from grade 11. Okay, where you have 180 minus, 180 plus, and 360 minus. You need to be able to express both for sine, for cos, and for tan. You need to know how to express those. And like I said, the shortcut of your calculator where you substitute 1 in the place of theta will help you be able to know what the sine of that trig ratio is without thinking. So it's a shortcut and it helps a lot, all right, so that you do not mess up the sign. Okay, and then lastly, you need to know your co-function values. Remember, your co-function values are 90 minus, 90 plus, 270 minus, or 270 plus, and that's where the trig ratio will change from sine to cos. If you were given sine, the sine will change to cos, and then if you were given cos, the cos will change to sine. Okay, so this is all the tools you need when you are doing any problem. Now, what I'm going to do now, I'm going to do a few problems that have to do with trigonometry, and I'll do different types of problems. Yes. Definitely thick Lerato, that's the truth. 180 and 360 plus are reduction function values, whereas 90 minus, 90 plus, 90 plus, 90 and 270 are co-function reduction values, which is very important, and that's where sine and cos interchange between the two. Okay, so let's look at a few problems. First and foremost, let's look at a problem that has to do with identities. Okay, so this is my grade 12s. Grade 12s, I'm moving with you today because yesterday I was moving with the grade, yes, that's true, Tabo. Okay, so let's look at this, guys. Let's look at this. If we were given a question and they said, write down the expansion of cos A minus B in terms of trig ratios A and B. Okay, so write down the expansion of cos A minus B in terms of the trig ratios A and B. So my grade 12, if I am going to answer this question well, write down the expansion of cos A minus B in terms of the trig ratio is A and B. Then what I'm basically being asked to do is to expand cos A minus B in terms of A and B, meaning in the mix of my expansion, I need to have A and B and some trig ratios that involve that particular A and B. So, declarato, definitely, it will be cos A, cos B, you are spot on, plus sine A sine B. So you are 100% correct, and I would give you 100% marks. First and foremost, the A and the B are there as they had asked, and plus we have some trig ratios, which means cos, sine, sine. So that would be my number 1. Then let's say they ask a follow-up question. They say use 1 and deduce cos 90 degrees minus d equal to sine of d. So they are asking me to use what I got in number 1, okay? Or they would have said maybe hence, okay? Guys, in mathematics, the word hence means use something that you did above. Use something that you did in the previous question and deduce. In other words, you need to conclude that cos 90, or you need to work out or show by working out from what you did here that cos 90 minus d is actually equal to sine d, using the expansion of what you did above. So what we do here is we are going to take cos 90 minus d as it is, right? And we are going to use what? The expansion above. And we are going to write cos 90 minus d in terms of this expansion. Does that make sense? So cos 90 minus d is what? Cos 90 cos d plus sine 90 sine d. Because remember, in this question they are saying hence use what you wrote above and deduce that cos 90 minus d is equal to sine d. So I take then that left hand side, which is cos 90 minus d, and what I'm going to do, because they said use what I've done above, I'm going to take the expansion that I've written above and write cos 90 minus d in terms of that expansion. Right? So cos A is what I would say, but I say now cos 90. Cos B, now I'm not going to say cos B, I'm going to say cos D, plus, here we said sine A, so we are going to say here sine 90, and then here we have said sine B, which is the second angle inside the bracket. So the second angle here is sine D. So that's my first step, and that looks great if you ask me. Second to that, I'm going to follow that up. What's cos 90, guys? As per what I know, because cos 90 is a special angle, you know. And very quickly, I know a calculator you can use, but I just want you to remind you of something, that there's a mother graph of cos theta where we know that cos of 0, for instance, cos of 90, cos of 180, cos of 270, cos of 360. I'm just throwing this in here, all right? Not because of anything, but just so that we can learn something. Okay, cos of 0 is 1. Okay, you guys should know the shape of this mother graph. Cos of 90 is 0. Cos of 180 is negative 1. Cos of 270 is 0. Cos of 360 is positive 1. Okay, I know we should know this mother graph. Okay, so cos of 90 is 0. No? Now 0 times what? Cos d. Does that make sense? Plus sine of 90. Okay, so once again, there's a mother sine graph. Okay, I'm just putting this in here, guys, just for enrichment, okay? Because when you know these things off by heart, it makes life so easy. You have the sine mother graph. Sine 0 is 0. Sine 90 is 1. Sine 180 is 0. Sine of 270 is negative 1. Then sine of 360 is 0. This is the mother graph. Okay, and for me, this is how I'm able to remember these special angles: 0, 90, 180, 270, and 360 for sine and cos. I know those off by heart because of the what? Of the graph. So sine 90, guys, is equal to what? To 1. So we substitute in the place of 91, and sine d is just sine d. Now look at this, 0 times cos d, because I apply BODMAS. Remember, BODMAS says when you have different operations, you start with brackets, followed with what? With, okay, I usually refer to it as BADMAS, okay? Brackets, exponents, division, multiplication, addition, and subtraction. So if you have many operations, you apply BADMAS. Brackets, exponents, division, multiplication, addition, and subtraction. So there's multiplication, you don't really go for the addition if there's multiplication first. So we take care of the multiplication. 0 times cos d gives us 0, plus 1 times sine d, that gives us sine of d. And what's 0 plus sine d? That simply means the answer is sine d. Do you see how we were able to really prove that cos 90 minus d is equal to sine d if we use the expansion above? Because that's what the question was saying. Use 1, meaning this expansion, and deduce that cos 90 minus d is equal to sine d. So we grabbed the left-hand side, we expanded it, we got these values. For cos 90 is 0, cos sine 90 1. We used BODMAS so that we can be able to evaluate, and then 0 plus sine d is equal to sine d. Look at that. That's what we wanted. So that is the right-hand side. So we were able to prove, indeed, that cos 90 degrees minus sine d, minus d is equal to sine of angle d. Does that make sense, guys? I hope we are together. All right. So this is just me utilizing my knowledge of what I know, because the knowledge and the information is in my head. I know these things, okay? Let's move on to the next question. Okay, the next question says, which is a follow-up to this one, it also says use the same expansion in number 1 to prove that sine 90 minus e is equal to cos of angle e. The same expansion, guys. I need to use the same expansion of this one to conclude that sine 90 minus e is equal to cos of e. Okay. Now you are looking at this and you are like, Haibo, I need to use this expansion, this one. But say I don't have, and you are sitting here and you're like, but I don't have cos here, I have sine. Okay, so I mean, say if I take the left hand side, which is sine of 90 minus e, how in the world do we get this thing to become cos? So this is where I say to you, well, you know what, we can, and we can do it in the following way. All right, and I just want you to check out, I just want you to listen to this very closely. So what if we said cos of 90 minus 90 minus e? Please take a look at this, guys. So what I've done, I've used the function value, the co-function value 90 minus. Okay, do you see this? I used the co-function value 90 minus because I know the cos of 90 minus. Remember, 90 minus, what does it do? 90 minus is the one that changes sine to cos and cos to sine. Okay, so I can write sine 90 minus e as cos, the changed trig ratio, 90 minus. Remember, if it's 90 minus, it means I would change this cos back to sine. The 90 minus would fall away, and then I would write the acute angle, which would be equal to 90 minus e. So I use the co-ratio 90 minus so that I can write sine in terms of cos. I hope you are with me and you are understanding what I've just done here. Okay, because if I was to evaluate what this is, I get this back. All right, so what I'm doing is because I've been asked to write, remember, cos A minus B is equal to cos A, cos B plus sine A, sine B. I need to use this to show that sine of 90 minus E is equal to cos E. What I know is that sine of 90 minus e, if I take the left hand side, sine of 90 minus e, I can take this sine of 90 minus e and write it as the co-ratio. The co-ratio is cos, and I write sine in terms of cos. Why? Because I am interested in getting to use this expansion, because they've said I must use what I wrote in number 1, which is this expansion. I need to use this expansion to be able to prove that sine 90 minus e is equal to cos e. So what you then do is you take the left hand side, sine of 90 minus e, write sine in terms of cos, but then you use the co-ratio, 90 minus. Why do you use 90 minus? It's because 90 minus is the co-ratio that leads to a change in trigonometric ratio. This was what I basically explained in the beginning when I was talking about my tools, that if you don't have a comprehension and an understanding of the co-function values and the fact that 90 minus 90 plus 270 minus and 270 plus are the ones that change sine to cos or cos to sine, when you know that and you have that understanding, then you can be able to do these tricks of changing sine to cos using the co-function values. Okay, so if I would evaluate this here, I would get this back, because what would I say? I would say cos 90 minus this angle. What's 90 minus? It is a co-ratio. 90 minus is in which quadrant? It is in the first quadrant. How is cos there? Cos is positive. Then I would write the change trig ratio, because cos changes to sine, and then I would write the acute angle 90 minus e. So this is equal to that, and that is also equal to this. But I've just changed sine to cos because I'm interested in using this expansion. Now that I have sine in terms of cos, look at this. This is like my A, this is like my B. So now I'm going to expand it. What is this equal to? This is equal to cos of 90 minus e. Cos. This is like saying cos A, cos B. Does that make sense? Then remember, if there's a minus sign, that means I change the minus to plus. Okay, I'm looking at my formula sheet and I'm looking at my expansion of cos. There it is. So it's cos A, cos B, but now I'm going to say cos 90 minus e. Then I change the minus, which is, because it's a subtraction, to plus, and I say sine of 90 minus e. This is like my A, B. Okay. Now, let us look at each trig ratio and take care of it. What's cos 90? Remember, cos 90, read from my graph, cos 90 is equal to 0. So it's 0 times cos 90 minus e. Now, you can evaluate cos 90 minus e if you want. Cos 90 minus e is in the first quadrant, so that is sine of e. Okay? Plus, what's sine 90? Sine 90 is equal to what? To 1. So that's 1 times sine 90 minus e. You evaluate that, you get cos of e. Okay? And guys, look at this. If you apply BODMAS, 0 times sine e, obviously anything multiplied by 0 becomes 0. Plus 1 times cos e, that gives you cos of e. Do we see this, guys? Then the addition of these two, 0 plus cos e, gives you cos e. Genie, look at this, guys. This is the what? This is what I was looking for. I wanted to prove that this is equal to that using the expansion of cos A minus B, having been given sine 90 minus E is equal to cos E. So there it is. It is actually equal to cos E. Proven. Done. Dusted. Okay? Guys, I hope you can see this. Okay? Because we are asked to use the expansion. Okay? Yeah. Looks good. I would say it's actually pretty. It's pretty sweet if you ask me. Okay? Alright. let's move on to the next question that was asked there. Now, they are saying to me, for number 3, that I must use what was gotten in 1 again, meaning this expansion, the expansion of cos A minus B. I'm just going to rewrite it here because it's in the other page now. So I'm using the very same expansion. This time round, they said use that to do what? Use what we got in number 1 to show that sine of P plus Q is equal to sine P cos Q plus cos P sine Q. Alright, so let's see this one. How now do we use this expansion to find out that cos P plus Q is equal to sine P cos Q plus cos P sine Q? How do we get this to become that? That is the $1,000,000 question. So this is how we do it. So once again, I'm going to take the what? The left hand side, which is basically sine of P plus Q. How do I get this sine to become cos? This is how I do it. I'm going to say cos, once again, of 90 minus what? P plus Q. Okay, so I'm just going to use square brackets so that I can distinguish between what I've written. Do you see what I've just done here? Once again, sine of P plus Q. Because I'm interested in using this expansion, I convert the sine to cos, but I use the co-ratio 90 minus. And then this angle is P plus Q in brackets. Remember, when I evaluate cos 90 minus, I always write the co-ratio, which is cos changes to sine. Okay, and it would be, this would be equal to sine of P plus Q. Cos 90 minus P plus Q would be equal back to sine of P plus Q. So do you see now I have this sine P plus Q in terms of this cos A minus B. Now, because it's like that, this is like my A, 90 is like my A, P plus Q is like my B. This is one term, 90 is one term, P plus Q in brackets, because it's in brackets, that's also one term. So that's like my A, that's like my B, I have the minus sign. Now I can use this expansion. Hey guys, I hope you can see this. This here is very important. Now I can use the expansion. So what is the expansion? Cos 90, that's like cos A, cos P plus Q. The P plus Q is like my B. Then remember, for cos, the sign changes. That's plus. There it is, plus. Sine of what? 90, that's like my A, times sine of P plus Q. That's like my B. Yes, I'm using the compound formula because that's what I've been asked to use to prove that sine P plus Q is equal to that. So I've been asked to use that. So I have no other choice. Okay. Okay. Yeah, unfortunately I have no other choice. Okay, but you see something here that I'm realizing that, okay, so something that I'm realizing here is that this expansion, right, okay, it's good to see this, because what you can see now is that you have this cos of 90 and you have this cos P plus Q. Okay, so this expansion here, though it looks like it might help me to win, but it doesn't look like it will help me to win very effectively, because now it means I'm going to have to use the the compound angle P plus Q and expand it again. So that means I should have actually taken into consideration a very important thing. So what I'm going to do is I can see that this is just going to complicate my life. So here's something that we do so that we can assist ourselves. Okay, what I will do here is that I'm going to reconsider this here, cos 90 minus p plus 2. I think if I make that to be my b, it's going to make life a bit complicated. So what I'm going to do is I'm going to take this negative sign, I'm going to distribute it inside the bracket, okay? Because I've realized something. As I've been working, I realized something, all right, that it's going to make my life difficult. So what I'm going to do is I'm just going to distribute the negative sign. So I have cos of what? 90 minus p minus q. Okay, hopefully you can see that. And after doing that, I'm going to regroup what I have, and I'm going to express it as cos of 90 minus p. That will become my a, and then minus q on the side. So the square bracket, little bracket for 90 minus p, and then minus 2 on the side. Okay. Now there's a reason why I've done that. It's because I can see that here I'm going to just have another compound angle which I'm going to have to expand. It's going to make my life miserable. So what I then do is I'm distributing the negative into the p plus q. Negative p, negative times p gives me negative p, and then negative times positive q gives me negative q. Then I regroup. 90 minus p becomes my a, all right, and then the q becomes my b. I still have the minus sign in between so that I can retain the integrity of my using this expansion, because at the end of the day I need to use the expansion with the negative sign for cos, right? So it's cos, the a is 90 minus p, the b is then the q. So you see this one, I'm going to obviously not utilize this now. I'm going to use this here, cos of 90 minus p minus the q. Grade 12, this one. So let's do it. Let's expand. See now? This is my a, this is my b. I still have a minus. So this is still retaining the same integrity. Okay, now let's go. Let's expand this one. This one is nicely expandable. Cos of 90 minus p. See, I'm going to just evaluate a cofunction value, which is going to be straightforward, times cos of q. No double angle, no compound angle, which is sweet, plus sine of 90 minus p. You see, this one is straightforward. I'm just going to evaluate a co-ratio, which is sweet, and then sine of q. This is also sweet because it's one trig ratio. Very different from this one, because this one I was going to get this value, but then I was going to have to expand and then simplify. It was going to make life just a misery and a pain. Now to finish this off, what's 90 minus p? In which quadrant? It's in the first. What is cos like? It's positive, but then obviously we write not cos, but we write that co-ratio sine p times what? The cos q, right? Plus, we do the same thing with sine 90 minus p. We evaluate 90 minus p first quadrant. It is also the co-ratio cos what? Cos p, followed by what? Sine q. Done. Weren't we asked to prove that this sine p plus q is equal to this expansion? There it is. There it is. It's the expansion and it's 100% correct. Okay. And yes, we had to actually like maneuver a little bit. All right. So we're not considering this one because this was a direct result of actually seeing that if we move from here to this is going to complicate our lives, because we have another compound angle and another one. Okay. And really and truly, we want to avoid such as much as possible. So life then becomes easy. when we simply do what? When we simply reframe, distribute the negative sign, write cos 90 minus P minus Q, regroup 90 minus P, that's our A, Q is our B. And then we use the very same expansion to be able to get to the answer that we were asked to basically arrive at. So that's that, guys. Okay, that's that. That is that. Okay, I want to do a Pythagoras type question. Okay, which is a Pythagoras type question has to do with using the Cartesian plane. Okay, I just want to do one question, and guys, I will be picking this up tomorrow morning again, same time, 5:30. I'll continue with the grade 12 trigonometry. Okay, because I want to basically expose us to the varying questions that do come in trigonometry, and then we need to become familiar with those so that we can be able to be more efficient in being able to do the trig, because trig has a lot of marks, and basically these marks, they can't go to waste. Okay, so I'll be exposing us to exam type questions around this topic. Okay, and I won't, don't worry, Anat. If tan 2 theta is equal to negative 24/7, where theta is between 0 and 90, it says find without using a calculator the value of cos theta. Okay, find without using the calculator the value of cos theta. So once again, it says if tan 2 theta is equal to negative 24/7, right, where theta is between 0 and 90 degrees, find without using a calculator the value of cos theta. So this is a section of work covered in grade 10 and 11, but in grade 12 it comes up because obviously we now also have the knowledge of double angles. So the way we go about answering such questions is, there's a method, obviously. The method involves the following. One, you need to use the trig ratio and the given interval to sketch a right angle triangle, and I use the word RAT for right angle triangle, in the correct quadrant. But you need to first find that particular quadrant by doing the following. So what I'm going to do, I'm going to use this example to basically get my point across. So we have tan 2 theta, and we are told tan 2 theta is equal to negative 24/7. So in other words, they are saying tan is negative. That's the first thing. And then secondly, they've given you an interval that theta is between 0 and 90 degrees. Okay. Now, there are two things you need to do from this information. From the trig ratio itself, you are told that tan is negative. You need to ask yourself, where is tan negative? Where is tan negative? So in our Cartesian plane, you guys should know this ASTC. All trig ratios are positive in the first quadrant. Sine is positive in the second. Tan is the one that's positive, that's why there's a T, is positive in the third. And cos is the one that's positive in the fourth quadrant. So where is tan negative? Tan is negative in the second and the fourth. Then tan is negative in the second and the fourth, right? That much is true. Okay, I think there might be a slight problem with the question, because if tan is negative in the second and the fourth, then for them to have given us this particular interval makes no sense at all. Okay. I think there's a few things here that they did. And that is, I think they were supposed to have given us an interval, because it wouldn't make sense. Okay, so let's open this up. So 2 theta is between 0 and 180, because in the question, guys, it would have to be relevant, you know. It wouldn't make any sense for them to say it's limited between 0 and 90, because then there's no coinciding of what they have basically given us. So let me just beef up the question, and let's just fix it up there a bit here. Okay, so let me just restate the question. They're saying if tan 2 theta is equal to negative 24/7, where 2 theta is between 0 and 180 degrees, find, without using a calculator, the value of cos. And I think in this case, we'll say cos 2 theta. Okay, sorry guys. Hey, TikTok does its funny things here. Okay, here it is. Okay. Yeah, okay. Find without using a calculator, the value of cos 2 theta. I think, sorry guys, there were just a few things in the question that, you know, would not make sense if we were to state it in that way. So I'm going to say it again. If tan 2 theta is equal to negative 24/7, where 2 theta is between 0 and 180 degrees, find, without using a calculator, the value of cos 2 theta. Okay. So like I said, we need to use the trig ratio that has been given together with the interval that we have. Okay, the interval, guys, is this here. Okay, 2 theta is between 0 and 180. Okay, so basically that's the interval. We use those two to basically sketch a right angle triangle in the correct quadrant. Okay, there are 4 quadrants, and like I said, we need to know where these quadrants are positive. Where these trig ratios, sine, cos, and tan, are positive, and where the trig ratios are negative. So all are positive. Sine is positive, tan is positive, cos is positive, which means all the other trig ratios here in the second quadrant would be negative. Cos and tan, sine and cos, tan and sine would be negative in the respective. So if we're saying tan 2 theta is equal to negative 24/7, that means tan is negative. Okay, where is tan negative, we ask? It's negative in the second and the fourth quadrant. 2, the interval of 2 theta between 0 and 180. Where is 0 and 180? Remember, this is 0, 90, 180. 0 and 180 covers the first and the second quadrant. Does that make sense? So you look at the quadrant with the intersection of ticks, the most ticks. So the ticks would fall in the second quadrant. So what we do is we sketch a right angle triangle. This would be the point, the terminal arm we call it. Then we just complete a right angle triangle. And then the angle, okay, from here to there, that 2 theta, very important. Okay, yeah. Now we'll go back to the ratio, negative 24/7. Remember, guys, you are supposed to know that in terms of y, x, and r, tan theta is equal to opposite over hypotenuse for a normal right angle triangle, but that's y over r. Cos theta, so it's y over r in the Cartesian plane. Cos theta is equal to adjacent over hypotenuse in a right angle triangle, but that's x over r in a Cartesian plane. And then lastly, tan theta is equal to opposite over adjacent, which is y over x. Okay. Why do you say so, Mbus? Why do you say so? The thing is, here they've, Mr. MT Nkulu. So you're saying, think the question as cos theta, not cos 2 theta is tricky. No, the thing is we are doing grade 12 double angles. Okay, so it's a totally different story, Mbuso. We are not doing grade 11, it's grade 12. Okay, so we're doing double angles, and that's factoring in our knowledge of double angles. We are asked to find the value of cos 2 theta without using the calculator. All right, this is the setup. Tan 2 theta is equal to negative 24/7, where the interval we have is 2 theta is between 0 and 180 degrees. Okay, yeah. Okay, so let's just go here then. Okay, so like I said, yes, I hope you see that. So tan 2 theta is equal to negative 24/7. So let's see here. They are saying y over x is basically our what? Our tan ratio. So negative 24/7. Remember, this negative 24/7 will also signify that basically this is tan 2 theta. Remember, a negative divided by a positive. Remember, this is a 24 that's negative, they are saying, and this is a 7 that is positive. But we can write the negative 24/7 when we evaluate. The negative sign is for the ratio itself. So it's a negative 24/7. So let's go to our right angle triangle. Y over x. That means y is 24. We assign the negative sign to the x, which is negative 7. Why do we do that? It's because we know that in this quadrant, x is the one that is negative, whereas y is positive. Obviously, the quotient, in other words, the division of a positive and a negative will still give us a what? A negative 24/7. So we assign the negative sign to the x, and then the positive, obviously, because in that quadrant y is positive, we assign the positive for the y. I hope that makes sense. Then to find the missing value of r, what do we use, guys? We use Pythagoras. So we say r squared is equal to x squared plus y squared. So we use Pythagoras. R squared is equal to x squared plus y squared. Our r value, we are going to find x is negative 7. So we put it in brackets and we square it. Y is 24. We put it in brackets and we square it. Then we move. R squared is equal to what's 7 squared? It's 49. 24 squared. We use our calculator very quickly. 24 squared is 576. Then what do? We take the square root on both sides. 576 plus the 49. 625. We square root the 625. We get 25. So we write plus minus whenever we take the square root for an equation, but we know that r is equal to 25. Yes, CR7, I do have a YouTube channel. You can find the link in my bio. I'll be uploading this live session after I'm done onto the YouTube channel so that you guys can rewatch the session if you missed it. Okay, just subscribe and just join there. So we have r now is 25. So that means our x, we know very well, is negative 7. Our y is equal to 24. And then our r is equal to positive 25. Okay, r is always positive, guys, always positive. Okay, but the x and the y, they will all depend on which quadrant we have chosen on our Cartesian plane. I hope that makes sense. Then now, what did we want to evaluate? We were supposed to find the value of cos 2 theta. That's what they asked us to find, right? So we're gonna say equal to cos 2 theta, right? So of course, cos 2 theta, what will we then simply do here? Cos 2 theta, we know that cos 2 theta is equal what is cos 2 theta equal to according to our diagram? Cos 2 theta, because we already have the double angle here, right? So we're going to say cos 2 theta. When we evaluate cos 2 theta as a whole, okay, we know it's x over r, right? because we already have factored in the fact that this is the double angle. So now if we evaluate the cos 2 theta, cos for 2 theta will still be adjacent over hypotenuse, meaning x over r. What is our x value? Our x value is negative 7. What is r? It's 25. Okay, so we have negative 7 over 25. Okay, yeah, that's what cos 2 theta is actually equal to. Okay, let's say they had asked us another question. Okay, what if they had asked us to basically evaluate maybe something else? Let's say they had asked us to evaluate something else, then we'd basically be able to evaluate that particular thing. Okay, guys, let me hold it right there. Tomorrow I'll be picking up from where I left off for the grade 12s. Okay, grade 12s, I'm actually going to have a session with you in the mornings. 5:30 I think is actually quite suitable. So I'll do an 5:30 session. I know it's Saturday, but I guess those who want to really join, they will join. I'll see you then. But I hope this session was very fruitful. I'll be uploading this, like I said, onto the YouTube channel. Have a good day. I have to bounce. Work is calling. I don't want to be late. Take care of yourself, and we'll see each other again on the flip side. Yebo. And thank you as well, Anna Ditavin. Thank you so much. I saw the heart me that came in, and I really appreciate it. Thank you. So if you, the YouTube link, please guys, you can go to my bio. It will be there. It's there, the link, the bio, the YouTube link.